Hello everyone, this is again your junior high school math teacher, and for our lesson in Mathematics 9, I'll discuss about similar triangles. Now this is the 6th week lesson number 1. So after watching the video, you should be able to define similar triangles as well as illustrate similarity of triangles. So in this presentation, you would be able to investigate, analyze, and solve problems involving similar figures through appropriate and accurate representation. Now let us have this next slide, similar figures. From its definition, similar figures refer to two figures that have the same shape or two figures that have the same shape are said to be similar, no matter how much they are expanded or shrunk, the shapes remain the same. Take for instance, two triangles that are similar, provided that, or if and only if, two requirements are met. And these are, or should I say two conditions or requirements, and these are the following. The first one is their corresponding angles are congruent. And for letter B, the second one, the ratio of the lengths of their corresponding sides are equal, or corresponding sides are proportional. Also, any two regular polygons of the same shape are said to be similar. Take these illustrative examples, for instance. Now, suppose I have here triangle ABC, probably the smaller triangle compared to the bigger triangle DEF. Now, comparing these two triangles, it is stated that triangle ABC is similar to triangle DEF. This symbol right here is properly read as similar to. Again, triangle ABC, the smaller one, is similar to the bigger triangle DEF. If and only if the following conditions hold. Okay, so what we just did here is we placed the smaller triangle inside the bigger triangle in order for us to properly pair their vertices. Okay? So again, if and only if the following conditions hold. The first one is angle A is congruent to its corresponding angle D. Likewise, angle B, this one, is congruent to angle E. Finally, angle C is congruent to angle F. Okay? As indicated by the identical slash marks on the corresponding angles. Okay? Now, this is just one of the two conditions. Basically, corresponding angles are congruents. And what is the second condition? Okay. Oh, okay, we're not done yet. Let us discuss further about corresponding angles that are congruent. Now, suppose angle A measures 64 degrees. It follows, and angle B measures 80 degrees. And angle C measures 26 degrees. It also follows that angle D, which corresponds to angle A, also 64, Angle E corresponding to angle B is also 80 degrees. And finally, angle F corresponds to angle C is also 26 degrees. Okay, next. We go now to the second condition. Segment AB divided by segment DE is equal to segment BC divided by segment EF, which is also the same as the ratio of segment AC to segment DF. So basically, the second condition is that corresponding sides or the ratio of the corresponding sides are constant, or the corresponding sides are proportional. Okay? Now suppose on smaller triangle ABC, the lengths of all sides are given. The shortest side is 5, the longer side is 12, and the longest side is 13. And on the larger triangle, only one of those three sides so far is given, which is segment DE, whose length is 15. Okay? Now, you will notice that segment DE corresponds to segment AB, having a length of 5. So, what we're going to do is to determine the length of the other two sides of the bigger triangle DEF. So, how do we compute for the lengths of those remaining two sides from the larger triangle? So, basically, we make use of this proportionality of their corresponding sides. So, AB over DE happens to be what? 5 over 15. 5 taken from AB and 15 is taken from DE. So, if we're going to reduce this fraction to its simplest form, it will give us 1/3. Or that is 1:3. And this particular ratio is called what? The scale factor, or the ratio of similitude. Okay? Which means that for every single unit from the smaller triangle, there is 3 units, there is a corresponding 3 units on the sides of the bigger triangle. So, with this scale factor or ratio of similitude, we can now compute for the length of segment EF and segment DF. Okay? And that is, okay, so if we're going to compare the two, it means 15 is 3 times longer than 5. Now, based on the scale factor, it follows that the length of segment EF must be 3 times longer than 12, which is the length of BC. So, 12 multiplied by 3, that is 6. And to get the length of this side, it is simply 3 times longer than 13, which is the corresponding length segment AC. So, 3 times 13, therefore, DF is equal to 39. Okay? Next. Now, for number 2, suppose we have triangle LMO, which is similar to triangle XYZ. Suppose angle L measures 50 degrees. Then we could say that x, which is the corresponding angle for angle L, is also 50 degrees. And suppose angle M is 70 degrees, and angle Y, which is the angle correspondent of angle M, is also 70 degrees. Therefore, for the remaining angle from those two triangles, angle O, which is obviously corresponds to angle Z, both of them have the measure of 60 degrees. Okay? Next, for letter B, suppose LM is 8 centimeters or 8 units, MO is 9, and XY is 4. How do we get the length of segment YZ? So this is how we find the length of YZ. We form the proportionality of their corresponding sides. So, we have LM over XY, okay, is equal to MO over YZ, which is also equal to LO over XZ. Yan. Then, taking only two of those three ratios, particularly these two, since this is where we going to work on, okay, so we substitute the value of some of those segments here. So, LM is 8, XY is 4, this one, and MO is 9. Therefore, we can now determine the length of segment YZ by manipulating this proportion. Therefore, YZ has a length of 4.5 or 4.5 units, which is our answer. Okay? Next. Now, for activity 1, let us try to answer the following. So, we can only answer either true or false. Number 1, all squares are similar. So, it's true. All rectangles are similar. It's false. All isosceles triangles are similar. It's false. All circles are similar. It's true. All rhombuses are similar. False. Any two right triangles are similar. It's false. Number 7, congruent triangles are also similar. True. Any two segments are similar. True. Number 9, all parallelograms are similar. False. Next. Number 10, any two equilateral triangles are similar. It's true. 11, any two convex quadrilaterals are similar. False. 12, any two trapezoids are similar. False. Any two isosceles trapezoids are similar. So the answer is false. Next. Any two rectangles with equal areas are similar. It's false. And finally, number 15. Any two regular hexagons are similar. It's true. Okay?